Hello, Mr. Stride here. Let's do a little bit of a warm-up here. We are going to have a main method that's up here in this box. Okay, we're going to create an adventurer, Legolas. And he is an archer. And an archer is an adventurer, and we're going to talk a little bit more about how this works a little bit later. And we're going to have Legolas speak and Legolas shoot. So, if you look at the code over here, what will be the output? No pause button today. You have to pause and figure it out. All right, Legolas is going to speak. So let's see, Legolas is an adventurer. But wait, is he an archer? I don't know. Is he going to say there is no need to go alone? Or is he going to say and my bow? And the answer is, since we created an archer, it's going to say and my bow. And then when we shoot, clearly it's going to say their armor is weak at the neck. All right, we're going to learn more about this. We're going to learn the specifics as we go. So let's start going. We're going to learn about casting and polymorphism. And quite frankly, polymorphism, that's a pretty tough topic to get used to. You really have to play around with it quite a lot. You have to do the coding in order to get it. And even casting can be a problem. We're going to spend the majority of our time in the slide deck today working on casting. First, or not first, but by the end of this this video, you'll understand polymorphism, and you'll see, hopefully, why it's useful. You're going to see the flow of polymorphic execution, and this is the tough part, and we're going to practice this in code. And then we're going to practice casting. We're going to do that both in code and in these slides, okay? That's where we're going to start. So let's get ready to cast. Aw, how could you not like these pictures? Aw. You know what? We have a cat basket on the left. Oh, isn't it so cute, a cat basket? And you know what a cat basket can hold? Only cats. The poor little puppy on the right, he's a dog. Look how sad he is. And he can't go into the cat basket because he's a dog and he feels left out. All right, now that we're done with casting, I'm just kidding. Wait, this analogy works. Trust me, trust me. Oh, now we got a dog basket full of puppies. Oh, you know what a dog basket can hold? Only dogs. And you know what a cat isn't? A cat is not a dog. So a cat cannot go into the dog basket. Oh, the cat is even sadder than the dog. How do they do that? And they must have modified those eyes. It's just too unreal, too unreal. So far we've learned that a dog basket holds dogs and a cat basket holds cats. And you can't put a cat into a dog basket, and you can't put a dog into a cat basket. So how are we going to fix this? Well, we're going to create a pet basket. A pet basket! That's right, and we're going to use inheritance, and it's all going to work. So if you look at this diagram up here, we see that a cat is a pet, and a dog is a pet. And if I have a dog that is a pet, do you see that arrow? It's kind of tiny up here. That arrow, that means I can put a dog into a pet basket, okay? And I can put a cat into a pet basket. So a pet basket is quite inclusive. Do you see? Look at them hanging out in their pet basket together. They're wonderfully together, nice and inclusive.
Human sacrifice, dogs and cats living together, mass hysteria.
Okay, so how does this at all deal with casting? You ready? This identifier here, this is a basket. It holds what? Well, it holds dogs. What can I put into a dog basket? Into a dog basket, can I put a dog into it? Do you see how I go this way, the arrows? Well, let me go back. Can I put a dog into, yes, the arrow goes up that way. I can put a dog into a pet basket. Boom, yes. How about this? Can I put a cat right here into this basket? This basket is of what type? This basket's a cat basket. So look at that. Yes, I can put a cat into a cat basket. All right, here we go. We got a dog. Can I put a dog into a cat basket? Well, we already went over this. No, you certainly cannot. You can't do it. Now here we go. A dog into a pet basket. See, this is a basket. My identifier over here is like a basket. Type pet. Can I put a dog into a pet basket? Yes, it's inclusive. How about a cat into a pet basket? Yes. Now, can I put a pet into a cat basket? Well, let's see. What do you think? The answer is no. You see, because a pet might be a dog, right? And in this case, the pet is a pet. It's not even a dog and it's not a cat. The pet's a pet. And you can't put a pet into a cat basket. You can put a cat into a pet basket, but you got to go this way, okay? You look at the identifier. What are you putting into it? So can I put a pet into a dog basket? No. Now look down here. I got a new dog, a new cat, and a new pet. I got my shorthand initialization for an array, and I'm creating an array of pets. This is my pet array. What can I put into pet baskets? I can put a dog, I can put a cat, and you know what else you can fit into a pet basket? A pet. Yes, 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 this will work. I can put a dog, a cat, and a pet into a pet basket. Very cool. All right, let's look a little bit more at some of the nuances of casting. So I can create an animal, and I can put the animal into an animal basket. That works just fine. Now, can I cast, right here, just put in parentheses, the animal to a dog, and then put it into a dog basket? The answer is no, because this animal is an animal. It's not a pet. It can be any random animal. Okay, it might be a shark. It might be a bear. It could be a virus. I don't think a virus is an animal, but it could be any of those things except a virus. And it may not be a dog, so you can't. This animal does not inherit from the dog class, so this will not work. Now, did you know that if I have a cat, I can put a cat into an animal basket? Okay, now this is a cat, right? Can a cat scratch furniture? Don't you know it? A cat can scratch furniture. So why can't I have my animal scratch furniture? And the answer is because the compiler thinks of this animal as an animal type. It has access to the behaviors that only an animal has. And since any generic animal can't scratch furniture, like say, oh, I don't know, a blue whale, doesn't even have access to your furniture, is not going to be able to scratch it. So the compiler says, hey, as far as I know, this right now, the compiler says, I believe this to be an animal, and an animal doesn't have access to scratch furniture. So you get an error there. I can put it into an animal basket, but then I can't do cat things with it. I can only do animal things with it. Now let's say I create a cat. Oh, I have the animal over here. See the animal? That is a cat. See how I created a cat? Then down here, I'm going to take my animal and I'm going to cast it to a cat. Even though it thinks it's an animal, I'm going to cast it to a cat and I'm going to put it into another cat basket. Mittens. I'm going to cast it into Mittens, okay? Mittens, what a cute cat name. And that's fine because I, the programmer, am telling the compiler, hey, I know what I'm doing. I'm going to cast it. I'm going to cast it into a cat, okay? And an animal might be a cat. So I'm gonna do it. I'm taking control here. I'm gonna make it work. So I'm gonna put it into there. And then now that it's a cat, it has access to cat behaviors. So Mittens can scratch the furniture. Pretty cool here. Okay, now this error up here, we didn't talk about what type of error it is here. Because doesn't this look a lot like this down here? Very much the same. And here, I was saying this would be an error, and here, this is okay. So what's going on? So what happens is the compiler will do its best to tell you what it knows at compile time. It knows that an animal can only do animal behaviors. But when it comes to casting, the compiler gives up. The compiler says, okay, Mr. Programmer, okay, Mrs. Programmer, I'm going to let you figure out what is best. You are telling me that this animal identifier, because I know it's an animal identifier, it says right here, you're telling me it's a cat, I'm going to go ahead and let you do that. So at compile time, this will work. I'm going to stick this animal into this cat basket. But what happens at runtime, the runtime engine takes a look at it and says, okay, honestly, for realsies, is this animal a cat? And the answer is no, this animal is an animal. It's not a cat, okay? The inheritance does not work that way. If we looked at the inheritance diagram, cat is an animal is not a cat. The arrows don't go in that direction. So this will not work at runtime. You'll get an exception. Okay, we covered a lot of the concepts here, but really what we need to do is we need to get into code, see how it works. So when we do our code, I'm also going to talk about polymorphism. It's a big word. Poly means many, morph means to change, so it's the ability for the same code to be used with different types. Many different types use the same code, but they behave differently. They seem to morph. Okay, so one piece of code that behaves differently depending on the different types of objects that are there. So we're going to go ahead and create a project together, and we're going to play with some code. All right, we have an animal class. I'm just going to walk you through some classes here. I have an animal class, a pet class, a dog class, and a cat class. First thing you need to do when you come across a new project, if someone gives you a bunch of code, is you need to become familiar with the methods that are inside of it. So let's take a look. Right here we see a comment right at the top that tells us that it has no constructor. There's no constructor here, which means all I have is the default constructor. Has a method. It's an instance method that says to live life. What will it do? Well, it's going to live some random number of lives. It's going to loop through those, and it's going to eat, sleep, and maybe mate, and then it'll die, okay? It's going to eat, sleep, and maybe mate a few times. When it eats, all it does is simply say, this plus eats. Wait a minute, wait a minute. What do you think this does? Think about that a second. If I run the code for eat up here, it comes in here, it's going to do this plus eats. What it's going to do is it's going to go to this object, whatever object this may be, and it's going to go to the toString method. So if you're an animal, it's going to return animal. So if I have an animal class, and I say eat, it'll say animal eats. When I go to sleep, it'll say animal sleeps. Now maybe mate, what it does is it's going to assume it's going to be false. It's going to pick a random number, and if it's less than 0.5, it's 50-50 chance. It's going to say that this animal has a baby. How cute. And then it mated. Okay, and then it's going to return true or false if the animal mated. Dies, it just says the animal dies, and then we already saw the toString here. Okay, so now let's look at the pet class. The pet class extends an animal. That means pets are animals. And every pet has a name because we give pets names. And so since I wanted to have a name, that means in the constructor, when I create my pet, I'm going to give it the name. I'm going to make sure that my instance field name is the name that was passed in as a formal argument. Since I may want to get access to that name, I'm going to have an accessor, okay, a getter or an accessor that's going to return the name. You can't set it, though. You can only set it through the constructor. Pets can make sounds, okay, and all I'm going to do is I'm going to print line whatever the sound is, and so I have another public method that says just give me the sound, and by default pets sneeze, all right? We all seen our pets sneeze. I think even birds sneeze. I don't know about that. And then of course we're going to have the own toString. So when I ask this object to print itself, it's going to say pet, and then it's going to give me the name. So that's what a pet does. Let's look at dog. A dog has no constructor, so it's going to use the default constructor. And then we're going to override the make sound. So if you saw that here, we had a make sound method here, okay? A make sound. Oh, do you know, I should probably override get sound too. That's kind of a funny thing. I don't want to override make sound. Let's come into here. I'm going to override get sound, and then I'm just going to return woof. That's better. That's the sound I want to make. Very good. We'll override get sound. Doing this on the fly. Okay, so when I ask the dog, what sound do you make? It's going to say woof. And then we're going to extend the pet class. We're going to extend, make a dog do something specific to a dog. And we're going to have it play fetch. So when I do play fetch, it's going to get the name, and it's going to say, I like to chase sticks. Okay? And we're going to do something to the cat as well. So let's go ahead and change that as well right there. We're just going to have it return a meow sound, right? And return meow. I like that. And again, we have no explicit constructor up here, so we have the default constructor. And then cats, as we know, they love to scratch furniture, so it's very specific. So it's going to be very pompous and say and then whatever the cat's name is, have claws, right? And then I should probably then here. Let's just add something. We need to add this, right? It's furniture destroyed. Okay, because that's what they do. They destroy your furniture. Dogs can too, but in a different way. They usually eat it. Okay, all right. Now let's take a look at my main method. My main method, okay, is that I'm going to create an array of pets. I'm going to print out that array of pets directly. I'm going to go through each pet in my array. I'm going to have them make a sound. Okay, then I'm going to make the first pet make a sound. Then I'm going to make the first pet scratch furniture. Why? Because look, you can see up here that my first pet is a cat. Okay, and then I'm going to make my second pet play fetch. So that's our goal. That's what we're going to have happen here, and we're going to play around with this some more. Okay, so the screen is a little bit small for you, but I'm going to come over here and I'm going to hit compile on this guy, okay? And then we're going to see what happens when I compile. And oh my goodness, I have a load of errors. So here's my error right here. It says, error constructor cat in class cat cannot be applied to given types. That's really confusing. Constructor cat in class cat cannot be applied to given types. So in my cat, well, I don't have a constructor. Oh, when I don't have a constructor, you know what constructor was written for me? The default constructor will look like this, right? And then it'll just be empty. So that's the default constructor. Then we also learned that a default constructor will call the superclass. So that's what I have. Now, when I changed it, did I fix anything? And the answer is I did not. Because if you look at my main here, I'm trying to send in a name to the cat. So what I really want to do is I want to give a name here, string name. And then I'm going to pass in the name to my superclass, the pet. So my pet has the constructor that takes a name. But wait a minute, don't I inherit from pet? Cat extends pet? I do. How come I didn't get that constructor from my parent for free? I get other methods for free. Why not my constructor? And the answer is because. Yeah, because. It's really important note. Constructors are not inherited, okay? I can't tell you the number of times I've seen this question appear on tests, AP exams. They ask you if constructors are inherited, and the answer is they are not inherited. So I don't get that constructor for free from my pet, but I still want to set the pet name. The only way I can do that is to call the constructor, and the best way to do that from a cat is to call super with the name. So let's see if I compile again. Did that error go away? I'm going to clear this so we can see, make sure we got it all clear. Okay, so I compile, boom, hey, I got a different error. This time it says constructor dog in class dog cannot apply to given types. You know, that seems like very much the same thing. Oh, yes. Let's make our dog constructor. Okay, it's going to take a name. And then I'm going to pass it into my superclass, and I'm going to pass the name in there. All right, so now I can call from my name, I can call new dog with a name Fido. Okay, that'll totally work. Totally work. Because when I pass in Fido into my dog, it goes up in here. Then I pass that into my super, and the name comes there. How cool is that? Question: Do I have access to the name of my pet? Like, for example, could I say, oh, how about here? System.out.println I plus this dot name plus will speak. Can I do that? That's the question. This dot name, well, there's no this dot name in a dog, right? It comes from my pet class. Pet has a name. But you know what? The pet name is private. So if I try to compile this, and I go to compile, all right, I get these, it's further down the list. Further, where is it? Where is it? Where is it? Boy, is it way down the list. Right here, okay? It says that this dot name does not, I don't have access to it because it's private. So I cannot do that. So that has to go away. How would I do it if I really wanted to do that? I would have to use my accessor and say get name, just like that. That would work, okay? I don't want to do this just now. I'll comment it out. We'll do that later. Let's look at our top. Oh, you know what? I forgot to save. Let's clear this and compile again. See where we're at. Okay, top of the method. Cannot find symbol arrays. That's because I forgot to do import java.util.arrays. So that'll take care of that. One error at a time. Whenever you get these things, you got to go one at a time. Okay, cannot find the symbol scratch furniture. Scratch furniture. You know what? I'm going to just take that out. I have that in my comments right here. I can't do this because only cats can scratch furniture. What is my pet? It's a, well, as far as the compiler knows, the compiler thinks it's a pet. And the only thing pets can do is everything that an animal can do, plus make a sound, and I can get the sound, okay? And I can get the name. So really, there is no scratch furniture for a pet. So a pet, as far as a compiler is concerned, cannot do that, right? And then we have cannot play fetch, all right? So we're gonna come down here, and we're gonna comment that out. We're gonna take care of that later, okay? Then I come down to here, and this error says, incompatible types, possible lossy conversion. What's going on here? Math.random is a double. I'm multiplying it by 3 or 5, then I'm adding to that. So I need to first cast it to an int. I gotta make sure I have this parameter after I do the multiplication, perhaps even after I do the addition. It won't really matter. I get rid of that. Let's clear, let's compile, and see what errors we have remaining. Oh my goodness. Okay. Void, sound returns a string. So we probably made that same mistake in our dog. Yes, we did. Let's fix that up. Clear, compile. Oh my goodness, the whole thing worked. That was all my errors. So now let's see what's going to happen. If I go to my main method here, okay, I'm going to create all of these animals, put it into my array. I'm going to output it. I'm going to set a breakpoint, okay? Breakpoint right here. I'm going to debug this guy. We're going to watch what happens when I debug this guy. All right, so I created my pets array, and I'm going to print this out. So when I take one step for the print, look at that. pet Pepper, pet Fido, pet Rando. Pet Rando. Because pet, when I ask for the, when I do the toString, it does pet, and then it gets the name. How cool is that? It's very, very cool. Now, wait a minute. What if I went to cat? You know what? I'm going to change this. This is not fun enough. Okay, we're going to change this, and we're going to do public string to string. Okay, and then we're going to do something that cats are cool. So they're you know, they have to be something. Let's see. Me, myself, and I are get name. But you know what? That's not cool enough. We got to do meow, myself, and I. Yeah, there we go. Our get name. All right. Now let's run this guy. Okay. We got to run this guy, run this guy, run this guy. And I get to here. I'm going to take my step. And what do I see? Boom, boom. Meow, myself, and I are Pepper. And then I get pet Fido, pet Rando. That means that when I'm asking the element in the array to give me its name, or to give to print itself, right? When I'm asking it to print itself, it does this for a cat. Whereas a dog, what does a dog do? What does a dog do? How come a dog doesn't have anything here? I don't get it. Why doesn't a dog have anything? Didn't it print? Didn't it? Yes, it did. It said pet Fido. Well, I didn't overwrite it, so it's going to get exactly what we had inside of the pet class. Okay, so this is the pet class here. And in the pet class, it has toString, so it's going to do that. Exactly great. Okay, so now we're in main. I'm going to go through and I'm going to get each pet. I'm going to tell each pet to make a sound. So when I step in to make a sound, I got my pet. Where am I going to go? The first element is a cat. So I go, wait a minute, make a sound. How come I'm in a pet? Oh, because in my cat class, I didn't override make sound, I overrode get sound. So here I am in my make sound method, and it's going to print line whatever get sound is. So if I step into that, boom, now I'm in the cat when I get the sound. So I come back out, I'm going to print that, and what you'll see is in the output window is meow. We just had the pet class call a method called getSound, and it didn't go to here. But wait, I'm in the pet class, right? Yes, clearly I'm in the pet class. So when I call getSound, why didn't it go here to get sneeze? And the answer is because I'm talking to a cat, all right? And a cat, no matter where to you talk to it, no matter where you're talking, where you're standing and you're talking to a cat. If I'm standing in my living room and I say, hey cat, make a sound, it's going to make the sound that a cat makes. It's going to, well, if it listens, it'll say meow, right? But if I'm outside and I say, hey cat, make a sound, it's still going to say meow. But if I'm in my bedroom where is me and only I belong and my cat somehow is there and I'm telling the cat to make a sound, well, it's still going to make a cat sound, right? Because I'm telling the cat always behaves like a cat. This is polymorphism. We're behaving differently. So let's continue on down through. Now I went through my second pet here, okay? I got my second pet in my array as a dog, okay? So where am I going to go first? Where am I going to go? Am I going to go to the dog? I don't have it. I don't have a make sound. There's no make sound here. Where am I going to go? Am I here? I'm here. So I step in. Oh, I'm in the pet class, make sound. And then when I step in again to get sound, look, here I am. I'm in the dog class because this is what dogs and cats have in common, is that when you tell a dog to do something, it's going to be a dog, okay? You can tell it to stop acting like a dog, and it's always going to act like a dog because, well, it's a dog. So even though I was in the pet class, it jumped into the dog class to make the sound, to get the sound. So if I step through here, come back out, I'm going to my third one, which is my random, total random pet. It's going to be a pet class. If I tell it to make a sound, it's going to go into pet. And then because the pet is a pet, it's neither a dog nor a cat, it goes into the pet class and it's going to get the sound and it's going to print line, sneeze, cat, dog, pet. Okay, so we made all those noises. How cool is that? Come down through here. Now if I want to make a sound, I'm asking my pet to make a sound. Pet 0 is a cat, right? We already did this. So when I step in to make sound, it goes into pet, then it goes into the cat to get the sound it's going to make, then it's going to print it, and we should see meow down here again, and we absolutely do. And then we're done with our code, right? Just done. But there's more we need to cover, right? Absolutely more that we need to cover. What if I wanted to have my pet scratch furniture? Now, if I do this, right, and I try to compile it, we've already seen that the compiler complains. Okay, we've seen this right here. It can't because the compiler thinks this is a pet, not a cat. So how do I get it to scratch furniture? Well, I tell the compiler that I'm boss. So I'm going to say, this is a cat. I know it's a cat. You're going to take that pet at the first location and you're going to cast it to a cat. Then you're just going to trust me. It's going to scratch furniture. Okay? So let me compile it. And if you didn't believe me, that worked. So now I can scratch furniture. How cool is that? So if I run through my code, I go through all my meowing and stuff, and I say, I, Pepper, have claws, furniture destroyed. It scratched furniture. All right. Now, how do I get it to, how do I get the second one to play fetch? Yeah, it's the same concept, right? It's a dog, right? So dog has to be cast to the dog class from the pets object because I, the coder, am overriding the knowledge of the compiler and I say, yes, this is a dog. We can play fetch. This compiles, and when I run it, it runs through it, and I have the cat, Pepper, destroy the furniture, and then I have Fido likes to chase sticks. Now what happens if I change this to dog, okay, and I cast it to a dog? Will it compile? There we go. I'm going to hit the compile button. Oh, wait. It didn't compile, even though I told it was a dog. Error, can't find symbol scratch furniture. I totally thought that would work. Hey, we're learning something together. Only cats can scratch furniture. Oh, wait a second. Yeah, okay. This is, I told it was a dog. Of course, I have it right. I wanted to play fetch, right? Not scratch furniture. I wanted to play fetch. So I'm telling my cat that it's a dog. I'm getting that on my array. Okay, let's compile. Whew. I'm still learning. I'm learning that I'm stupid. That's what I'm learning. Okay, I compiled. Everything worked. If this compiler worked, it says, the compiler says, okay, Mr. Compiler, Mr. Stride, you think you know what you're doing. You're telling me it's a dog. I'm going to let you win this fight, but I'm going to win the battle. And so when I run this guy, it comes all the way through, and then BAM! Okay, I get a class cast exception right here. Okay, it's right on line 26 because the runtime environment says, hey, I truly do know what's in here. I can look in the basket, and I don't care what you think it is actually cat. So that did not work at all. So I can't cast a cat to a dog and fool the runtime environment. I can only fool the compiler. Okay, so that's just not going to work. What else can we do with this code? You know what? I'm going to make this animals. Animals, 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 because we have pets, and you know what they are? They're animals, and we have this animal class. It's going to do stuff. So let's do some more stuff. This is fun. So can a cat fit into an animal basket? Dog and a pet and all that kind of stuff? You betcha. Okay, I'm going to still come through here, but now when I go through my array, I'm going to make it animals. Okay, it's animal singular, animals plural. So I'm going to come through. I'm going to go through this is my animal, and I'm going to go through my animals. I'm going to have it make a sound, okay? Whew. Can I do that? Do all animals make sound? That's the question. I got to change all of these. I should have done it better. Animals. Okay, clear, compile. And of course I have some errors here, so that's the pets needs to be animals. I should have known. I should have known. Let's compile it again. And wait a minute. Wait a minute. Are you telling me that an animal can't make sound? What if I really wanted to make a sound? What do I do? Well, I can cast it to a pet, right? What if I want to make sure that it's really a pet, though? What if I do new animal like that? Now I have an animal in here. And what if I change up here and I go new animal, and I have all those animals inside of my animal array? I can put an animal in an animal basket. I can put a pet in a pet basket. I can put a cat in a dog. I can put all those things into that basket. Now when I go through the array, if I want to make a sound, only if it's a pet. So I can do this. If animal, if it was an instance of an animal, then I can make, no, if it's an instance of a pet. If this instance was a pet, if this was an instance of a pet, then I can go ahead and make a sound. Whoa! That means what I'm doing in here is have all pets make their sound. So if it's not a pet, it's not going to make a sound. I'm asking the object, this is asking the runtime compiler, which appears to be all-knowing, is that if this guy right here is a pet, then go ahead and make a sound. Oh wait, I'm still not done, because only pets can make sound. So I have to tell the compiler that yes, this animal and a meal, this animal is a pet. Okay, so I can have all pets make a sound. So, gosh, let's see if this goes. Oh, please. Wait, oh, down here. Oh, same problem, right? I need to cast it. So, you know, I'm going to do some shorthand notation right down here. I'm going to tell it that it's a pet, because I know at this moment 0 is a pet. Thank goodness it's still a pet. So I'm going to say that 0 is a pet. Just going to cast it just like that, put some parentheses around it, say that's a pet, and make a sound. Does that work? Cross my fingers. That worked. That totally worked. What did I have down here? How come that worked? Oh, because I'm already doing my casting. I'm saying it's a cat and a dog. Do I have cats and dogs in the first? I still do. All right, what happens when I run this puppy? When I run, I print out all the animals. Okay, and so then I get my Fido to print, and animal just prints animal, because in my animal class, my toString down here, my toString is an animal, right? It's right there. And so then I have my pet rando, and then another animal, and all the pets that were all the animals that were pets, they printed themselves out, or they made their sound and they went through that. Gosh, that was really, really cool. That was awesome. But you know what? Most of the time in your coding, that when you use instance of, there's oftentimes a better way. Now in this case, if I just want pets to make their sound, I could do that. But maybe I would make, as a sound, making their sound, maybe that's an animal's action. Maybe that's what an animal does. It's an action. So instead of doing instance of, maybe I want to give each animal their action. So I'm going to do public void action. I'm going to say do action, okay? And then right here, for an animal, we're going to do nothing, okay? We're just going to do absolutely nothing because just a regular action doesn't do anything. And then for my pet, my do action, what do we want it to do? We want it to make a sound. So that was called make sound. So what I've said is that all animals are allowed to do an action. I made sort of, what I tried to do is I tried to be abstract. All animals can do an action, but if I don't know, if I'm just a regular animal or an abstract animal, I'm not even like a pet or a dog, or I'm just an animal. I'm not even like a lot. You have to be something, but I don't know what I am, then I do nothing. But if I'm a pet, then I'm going to make a sound. What will dog and cat do? Well, they are pets, so they're going to inherit the action from the pet, and they're going to make the sound. When they make the sound, they're going to print line sound, and when asked for the sound that they make, then they'll go to the dog or they'll go to the cat. So let's compile this. Everything still worked, but I forgot to change my main. My whole point of this was to get rid of this thing. I don't want to do that. Instead, all I have to do is to be more abstract with what I want it to do and have it do an action. Okay, so I'm going to do animal dot do action. Okay, and then let me just get rid of all that stuff right there. So now hopefully my output will be exactly the same when I run it. And it does run, and if we look down here, I have all my animals make their sound, and if I have an animal that's not a pet, I have all my pets make the sound. If I have an animal that's not a pet, then it just doesn't do anything at all. This is making use of, what is that big word again? What is it, big word again? It's making use of polymorphism, okay? Polymorphism. So let's review a few things that we've done here. We had to fix up our dog constructor to call the superconstructor so that we can initialize the private instance variable, which is not given to the it's not given to the subclass. We had made use of polymorphism when we make a sound because we get the sound from the object that it is. We made use of toString to print stuff all over the place. We did that. We did that here in printing the stuff, and we do it here when we print. The arrays toString goes through all the objects and animals and asks the objects themselves to give them the toString. We learned how to cast a specific object to the type. Here we did it in line. Here we're doing it in 2 lines. This can be a little more understandable. It takes an extra line. And we learned how if you cast to the wrong type of animal, that the compiler is okay with that, but then at runtime, we will throw an exception. There's a lot of stuff in there, okay? The hardest part, I think, about this is understanding which type of objects can go into which type of baskets. So make sure you're looking at your arrows of inheritance to know which direction objects can go, because I know it's pretty easy to know that a cat is a pet and a pet is an animal. But in the future, they're going to say class A, class D, class W, class foo, class bar, and you have no idea what the inheritance model is, so you have to draw out the diagram to see which way the arrows go. And then you can see that when we do the assignment, okay, the assignment goes from the right side into the left side. And so we know if the arrows in our diagram match the arrows the way we're putting stuff into the basket over here of this type, then we know that we can do it. So The casting can be tough. The polymorphism is especially tough. Just know that no matter when or where I am, a cat's always going to act like a cat. So even if I'm in pet code, but the object is a cat, it's going to act like a cat. Doesn't matter which house you're in, which class you're in. If the this object is a cat, it's going to act like a cat. And it just takes practice to kind of get used to it. When will you use it? Use it for arrays to hold random stuff like this. It's one way to use it. Um, it's often used that way, and it's used also in interfaces, which thankfully in this new year we don't actually have interfaces on the AP exam this year, so you don't have to worry about it. So it'll seem a little bit easier. All right. Hope that was fun. It was so much fun. Mr. Stride, when do we get to play again?